All right, so let's go ahead and get started with this. Yeah. All right, so we are recording. So we're going to start with equilibrium. Okay. So equilibrium. What does this part of the word sound like? Equal. Okay. So equal. This, and that tells us a lot about the word that we're dealing with today. When an object is in equilibrium, it has equal forces. So this is when an object, whatever object it is, has balanced forces on it. So balanced is the key. What does it mean to have balanced forces? Okay, they're the same. So let's consider Puppy Dog in this picture right here. Okay, Puppy Dog has balanced forces. Let's look at his free body diagram. He has his body, okay, and with his body, he has a weight. So we have the force of mass times gravity. Puppy Dog also, because he is on the carpet, he's on a surface, he also has the normal force. Okay? So, if the normal force equals the force of weight, then the forces are balanced. So, equilibrium is when an object is at rest. So, your desk is at rest right now. It is sitting still. If something is at rest, like Puppy Dog is at rest, what is their speed? Or what is their velocity? 0. Well, now you're getting complicated on us. But remember, the gravity, the acceleration due to gravity is considered in the weight. So, and that is relational too. Since we're all on the same planet, it's like we're all in the same bus, we're moving the same speed. So at rest is sitting still, is going nowhere. Okay. There is another, we can see from our picture example here, there's another way that we can be at equilibrium. So, not just in a Prius, but what can you observe about the free body diagram? So let's look at the free body diagram of the car moving in the picture there. We have our car, okay? It's got gravity, or the force of weight, okay? It's got the normal force because it is touching a surface, okay? I used two different things there, but then we see that we have the force of acceleration and the force of friction. We can make our fancy F for friction. Okay? What do you notice about the arrows? The car's still moving forward. Okay? So if we have a constant velocity, right? Friction equals acceleration. I should have wrote that first. We could do it right here. Friction equals acceleration. Okay. Constant velocity. So there is a scenario in this one, the constant velocity, when an object is moving, but it is in equilibrium. Constant velocity. So let's kind of add to this just a little bit. If velocity equals speed, and that's a very loose interpretation, velocity is a vector, whereas speed is scalar. So what's the difference between velocity and speed? Let's go back to that idea. If velocity is a vector, speed is a scalar, what does velocity have that speed doesn't? A direction. Velocity has magnitude and direction, whereas speed is just magnitude. But nonetheless, we're still talking about distance over time. So we're going to kind of keep that one here. But acceleration is a little bit different. What is different about acceleration? When you hit the skinny pedal in the car and the accelerator, what are you going to do? Go faster, speed up. So acceleration equals speeding up. So I'm going to go faster, faster, faster. Okay. I could also have negative acceleration. So we're going to talk about this just later on in a lot more detail. But if I have negative acceleration, what would I be doing? Positive acceleration, speeding up, slowing down, right? And negative acceleration is slowing down. All right, so really the big deal about today is that word equilibrium. Okay, equilibrium is our big deal for today. In this note section, we have two ways that we can get to equilibrium. When an object is at rest, or when an object is in constant velocity. So the friction equals acceleration. We're not sitting still, we're still moving like our car here, but we're not speeding up or slowing down. That speed is constant, is the same throughout.